Hello, my name is pvaquero, and today I will be talking about my project in recycling station. So the basic idea of this project is to convert the metal scrap of a company into different powders and then transform this powder into small metallic gears. So my presentation will talk about firstly the material selection. We could choose between three different materials, aluminum, steel, and titanium. Then I will be talking about the process to create my powder, which is going to be gas atomization. Then I will analyze the powder created, and finally I will design a station in order to perform the compaction and sintering of the previously produced powder. Regarding the material selection, I decided to choose aluminum rather than titanium or steel. The first reason is this, that it is a really lightweight material and really durable, which is a good property for years. Also, we want a material which is resistant to corrosion. And a really important property, it has a good recyclability. Some materials experience a loss in their intrinsic properties, but this is not the case of aluminum. So by converting the scrap into powder, there won't be any problem in terms of its properties. Then it also has a great conductivity. This is important because maybe gears concentrate heat, and so if aluminum is a good conductor, it is able to dissipate this energy. And finally, it is cost effectiveness. Basically, the aluminum is quite cost effective compared to the other two proposed metals. The process I selected to perform my powder was gas atomization. I chose gas rather than water, firstly because it has a better control of the particle size and its microstructure distribution. This will be very important for the mechanical properties of the material, and I will discuss this later. Then it also produces a higher purity. Gas atomization utilizes inert gases that do not affect the composition of aluminum, while water will induce some changes. In relation to this, also water will produce oxidation in contact with the aluminum, while inert gases don't. And finally, the use of gas atomization is also better if we want to produce a large volume of a certain product. In our case, which we are producing small metallic gears, we would like to produce high volumes, and so gas atomization has a better scalability and efficiency in this case. So now that I have already explained why I chose gas atomization, I will focus on this process. So the first thing we need to do is to place our aluminum in this spot, and the use of a crucible together with the electromagnetic energy induced by our coil will produce the aluminum to melt into liquid state. Then the material will flow, impacting gas, the inert gas jet that is sketched here in blue, and this will produce the formation of droplets um, that will quickly solidify. This rapid solidification will induce some important properties such as fine particle size, uniform spherical shapes, and the purity of the compound thanks to the use of inert gases. And finally, the powder is stored at the bottom of the device. Why are these characteristics important? Um, the fine particle size and the spherical shape are really important as they will induce good mechanical properties and also will improve the packing and compaction of our powder. So now that the process to produce our powder has been explained, we need to explain the analysis of our powder. How do we know if our powder meets our requirements or not? So the first thing we need to do is to take a sample of our powder and put it in the microscope. And firstly, what we would like to observe is whether the shape of our powder is spherical or not. To do so, we will increase the zoom of our microscope for a number. I wrote here 100 times of zoom. It's just an estimation. And when we see the spherical shapes, this will give us an important piece of information. The first thing is that the spherical shapes implies that our material will have a better formability and packing density. This means that when we would like to perform the compaction and sintering, our material is highly likely to be able to be compacted in an accurate way and with less internal defects, thanks to the packing density. Also, the spherical shapes of the powder implies that it has a better coating adhesion. For instance, if we want to perform subsequent processes after the powder, we will have an advantage in this point. And finally, it will also induce a uniform sinkerage in sintering, which will minimize the distortion in the final gear assembly, which is also really important as our gears are really small and need to be really accurate. Now we can also increase the zoom in our microscope. I wrote here like 10 million zoom. This will cause us to see a fine microstructure. This is what we expect. Um, the fine microstructure implies that our material has a great strength, hardness, and wear resistance, which of course is a really important property for a gear. Also, as mentioned before, it will also have a better corrosion resistance. And a really important factor is the better surface finish. Um, Basically, in a small gear, the surface finish is really important uh, for the gear teeth, as we want to minimize friction. We don't want to have a non-uniform surface finish because this would cause an alteration in the load distribution. And finally, also a really important um, property is that the finer microstructure has a better dimensional accuracy and tight tolerances. Tolerances are fundamental in gears because you need to meet certain standards. Having a fine microstructure will be a crucial factor to take into account. Finally, we can talk about the compaction and sintering. So now that we have our powder manufactured, we would like to create our gears. The first step will be to compress or compact our powder. So I have drawn here a kind of a mold. In the basis, we will have the powder. Okay, so the powder will be here. Then we will apply a force. This will be compressed, and after having it compacted for some time, we will take away the part which is called as the green product. Basically, the green product has certain characteristics such as the green strength, which is, for instance, related directly to the force applied. Higher pressures or higher forces applied will imply our green product to have better properties and strength. Now, the green product has this microstructure, which can be observed here. So the particles are not compacted. Its microstructure is not compacted. So we need to uh, sinter the product. Here's the conveyor belt. So the gears will go through here in this way and will be introduced in a kind of furnace that will provide a heat, uh, a control heat below its melting temperature. Okay, so the temperature has to be lower than the melting temperature, in this case of aluminum. And we will leave there for some time. And the sintering process will create, as you can see here, its microstructure to to be transformed. Firstly, the green powders and the microstructure is not very unified, and with the application of heat and time, we will reach to a sintered product in which the microstructure and the powders are highly compacted. And after that, we will have our sintered product manufactured. And as it will be really hot, we need to leave it for cool for some time in room temperature. And that will be the process of manufacturing the small gears. So thank you very much for your attention. I hope you enjoyed, and thank you very much.